So we're going to be solving a quadratic formula or quadratic functions again today. I'm going to start with a linear equation, and for this one, what we're going to do is we're going to say, well, what's the value of x when y equals 0? So we want to know what x is. So what we could do, we could plug in for y, we could plug in 0, and then just solve for x. And so 2 times 0 is 0, so we get 8x equals 16. Divide both sides by 8, and we get x equals 2. So we get a solution pretty easily with something like this. And what we could do is we could say, well, let's just make, if I had a whole bunch of these equations and we wanted to solve for x very quickly, what we could do is we could create like a general equation that would allow us to solve it very fast. And so what we could write is like, let's do ax plus by equals c. And then again, we want to know when y is 0, what would the value of x be? And so if we plug in y equals 0, we would get a times x plus, and then b times 0 equals c. And now we'll just solve for x. So we divide both sides by a, and we get x is equal to whatever c is divided by a. And that's the value of x when y is 0 for any linear equation. So it's kind of like a general form. So if you wanted to know where does this line cross the x-axis and what's the value of x when that happens, so if you had some line like this, what we're looking for is this point right here. Where does it cross the x-axis? And it's always going to be c divided by a would give you the value of x. So that'd be this distance from the y-axis to the point. Okay, because remember we set y equal to 0, so that means that we're on the x-axis. Okay? So what we can do is we can try to do something like this, where we come up with a general form like this for a quadratic equation. If we wanted, as an example, if we had, say, something like 10x plus 4y equals 15, and I wanted to know what's the value of x when y is equal to 0, I could just plug in the a and the c into this formula here. This is kind of like our little formula that we created by solving this general form here. And so if I plug that in, I could say x equals c is 15, a is 10. So it would be 15 tenths or 3 halves. So x would be 3 halves. That's the value of x when this line that would be created if we graphed this. The value of x would be 3 halves. So what I've done is I've inserted a Desmos, a snapshot of a Desmos and graph of this equation right here, 10x plus 4y equals 15. And as you can see, the point where it crosses the x-axis is 1.50, so the x value is 1.5, which is the same as 3 halves. So what we want to do is we want to try to do the same thing that we did right here, where we've got ax plus by equals c, and we said, well, let's try to make an equation where y is equal to 0, so we plugged in x or y equals 0, and then we solve for x. So let's make a general formula like we did here, where we came up with x equals c over a. So for any linear equation, we can solve for x when y is 0 by just taking the c and the a and dividing c divided by a. We want to do the same thing for a quadratic equation. Now it's a little bit more involved, and there's a lot more steps than what we have here. And so we'll start that right now. We'll go through it, and then once we get the formula derived, then we'll just use it. We'll just use the result, just like we could use this result right here. We'll do the same thing with a quadratic. All right, so here's a general form for a quadratic equation. We've got ax squared plus bx plus c is equal to y. And remember, we want to know what x is when y is equal to 0. So we'll substitute 0 for y. So now we've got this general equation. And now we're going to solve for x. And to do that, we're going to use what we know about completing the square. So we'll do that right now. We're going to start by subtracting c from both sides. So what we'll get is ax squared plus bx equals negative c. So now we have that. Now we're going to make this a 1 by dividing everything by a, like that. So now we get x squared plus b over a times x equals negative c over a. Okay, now we've got it in a form where we can complete the square. We can find out what we have to add to this side so that this becomes a perfect square trinomial. And if you'll remember, we just take this coefficient right here, we cut it in half, and then we square it. So if we wanted to cut b over a in half, we could divide by 2, or we could multiply by 1/2, and that'll be a little bit easier to see that this is b over 2 times a. So that would be b over 2 times a, and then we have to square that, right? If we're going to, that's the kind of the process for completing the square. So we cut that in half, and then we square it. So that would b over 2a squared would give us b squared over 2 squared times a squared, which is just b squared over 4a squared, just like that. So we're going to add that to both sides. So this is now x squared plus b over a times x plus b squared over 4a squared. And we have to add that to both sides. Just like that. Okay? Now we can write this, because we've purposefully made it a perfect square trinomial, we can write it as the square of a binomial, okay? And so that would be x plus b over 2a, quantity squared, and that'll equal whatever is on the right here. Just like that. Okay, we need a little bit more space here. So we've got this so far. And so what we can do is take the square root of both sides. Or actually, you know what? Let's combine what's over here first. We get a common denominator and combine that. Okay, so this will be still x plus b over 2a squared. And then the right-hand side, we need to multiply, to get a common denominator, we need to multiply this one by 4a over 4a. So that'll get us a common denominator for those, for negative c over a plus b squared over 4a squared. So that'll give us a common denominator of 4a squared. So we'll rewrite this. And this will become negative 4ac over 4a squared plus b squared over 4a squared. And so I can write that with a common denominator. It'll make it a little bit easier to work with. So we have this over and then 4a squared. All right, now what we can do is take the square root of both sides, because we've got this as a perfect square on the left, which was purposefully done so that we could take the square root. And so we'll do that. So we'll take the square root here, and we'll take the square root of this. So, and this will be positive. We want both roots, positive or negative. Give ourselves some room. Okay, so now we have x plus b over 2a on the left. And on the right, we've got plus or minus, and then we have the square root of this whole big monster here. Just like that. Okay. I think what we'll do now is we're going to simplify this right-hand side. So I can rewrite it so that we have the square root of our numerator divided by the square root of our denominator. So this would be x plus b over 2a equals positive or negative, and then we have the square root of negative 4ac plus b squared over the square root of 4a squared. Now this is cool because 4a squared is a perfect square. So the square root of that would just be 2a. So we'll rewrite that. This is x plus b over 2a equals positive or negative, and then we have the square root of our numerator, which is this, and our denominator is now just 2a. Okay, all we have to do is subtract the b over 2a from both sides, and we'll get x. So x equals, and we get, we've subtracted b over 2a, so that'd be negative b over 2a plus or minus the square root of negative 4ac plus b squared. All that is over 2a. Notice I already have a common denominator here, so we can rewrite this, and this will be our final bit. X equals negative b plus or minus the square root of b squared. I'm going to reorganize, minus 4ac, just like that. All of that is over 2a. And this is the quadratic formula. And you can use that to solve any quadratic equation. So let's use it. And really, you've got to commit this to memory here. This has to be memorized. So x equals negative b plus or minus the square root of b squared minus 4ac. All of that is over 2a. And there's songs and stuff that go along with it to help memorize it. But however you want to do it, just memorize that. Okay, let's use it. The square root of 1 is just... Okay, we've got an equation here on the left that we want to solve. And we have our quadratic formula. And so this is a. The coefficient in front of the x squared is a. The coefficient here in front of the x is b. And the constant is c. So we'll just take those numbers and plug them in over here. So what we get is a is equal to 4, b is equal to, that's a negative 9, because if we wrote it as an addition statement, this would be plus negative 9. And then c is equal to 5. So we'll plug those in to our quadratic formula. So x equals negative 9 plus or minus the square root of negative 9 squared minus 4 times 4 times 5, okay? And then all that is over 2 times 4, just like that. Go ahead and evaluate this. So this will be 9 plus or minus the square root of 81 minus 16 times 5 is 80. All that is over 8. So x equals 9 plus or minus the square root of 1 over 8. So x equals, sorry about that, the square root of 1 is just 1, so this is 9 plus or minus 1 over 8. And so what we get is 9 plus 1 over 8, or 9 minus 1 over 8. And that would be 10, let's give ourselves some room here, 10 over 8, or 8 over 8. So x is equal to 5/4 or 1. Those are the solutions for this original equation right here. And that's all you have to do. You just take the values that are there, plug them into the formula, or here, plug them in, evaluate, and then you will get your answer. We'll do one more here. And so remember, we've got a is equal to 3, b equals 8, and c is equal to negative 3. Take those and we'll plug them into the quadratic formula. So x, the solution for x with those coefficients will be negative 8 plus or minus the square root of 8 squared minus 4 times 3 times negative 3 over 2 times 3. So x equals negative 8 plus or minus the square root of 64 minus, and then that'd be 12 times negative 3, that's negative 36. Just like that. All that is over 6. So x equals negative 8 plus or minus the square root of 64 plus 36, because this is, you're subtracting a negative, so that would be 100 over 6. So x equals negative 8 plus or minus 10 over 6. And I'll just go up here with this. So this will be x equals negative 8 plus 10 over 6, or negative 8 minus 10 over 6. So this is 2 over 6, or negative 18 over 6. So x equals 1/3, or x equals negative 3. So there's our solution for this quadratic equation.